Hello everyone, welcome to another episode of Easy Chemistry Just for You. In today's episode, we will be discussing about the SI unit or the International Standard Unit. Why do we need an SI unit? Why are we learning about this SI unit? While performing an experiment, scientists used to study the property of the substances, and this involves measuring the quantitative property. A quantitative measurement means there must be a numerical value and an unit. For example, you can see a block of sulfur here, and the weight of sulfur is 200 gram. That means 200 is the numerical value and this gram is the unit. There were two kinds of measurement system, that is the English system and the metric system. These are some examples of unit of measurements under the English system, as the yard, foot, inches, miles, and gallons. In the system, there was no uniformity in the conversion of one to another, from one form to another. In 1791, French Academy of Science introduced the metric system. Under metric system, the unit of physical quantities are related to each other as the multiples of power of 10. So 1 kilometer is equal to 10 to the power of 3 meters. This system was found to be convenient and was hence used worldwide. In 1960, the metric system was improved at the General Conference of Weight and Measures. And this creates the International System of Unit or the SI unit, which is the short form of System International in French. The International System of Unit or SI unit have 7 base units. And these units pertain to 7 basic fundamental scientific quantities. And which are the 7 basic fundamental quantities? It's the length in meter, that is the name in SI unit, mass as in kilogram, time as in second, electric current as in ampere, thermodynamic temperature in Kelvin, amount of substance in mole, and luminous intensity in candela. These are the 7 basic SI units. And the other physical quantities such as speed, volume, density can be derived from this base unit. They are known as the derived unit. And the symbol for the length is L, mass is M, time is T, electric current is I, thermodynamic temperature is T. Whereas in SI unit, the symbol for the temperature is K, and for electric current it is A, that's for ampere. Time is in second in SI unit, and mass in kilogram, and length in meter. And the amount of substance is mole in SI unit, and the luminous intensity is candela in SI unit. Next, we have to study about some prefixes used in SI unit. There are a lot of prefixes, symbols and multiples given in the textbook. It may not be easy for you to learn all the symbols and all the prefixes. Some are very important, like nano, 10 raised to minus 9, 10 raised to minus 6, micro, and the symbols. Then 10 raised to minus 3 is milli, 10 raised to minus 2 centi, then 10 is deca, that is 10 raised to 9 is giga, 10 raised to 12 is tera, and all. You have to learn at least these symbols so that these symbols will be there in the numerical problems coming in this chapter. So you have to learn at least these symbols, multiples and prefixes. At least the multiples and prefixes. Mass and weight. Is there a difference between mass and weight, or are they same? Yes, there is difference between mass and weight. Mass of a substance is the amount of matter present in it. It's always constant. Mass do not change. It's the amount of matter present in it, and it is always constant. Whereas weight is the force exerted by the gravity on an object. Weight of a substance may vary from one place to another due to the gravity. So weight is equal to mass and the gravity. So mass into gravity. The force exerted by the gravity on an object. Whereas the weight will change according to the gravity, whereas the mass will be always constant. For example, weight may vary due to changing gravity. See, this person is on the earth, and if you are here, the weight is measured in Newton. So on earth the weight is 560 Newton. When this person moved to the moon, her weight will be 90 Newton, because the weight is always affected by the gravity. Whereas mass is always same. If the mass is 56 kilogram, it's 56 kilogram throughout. It won't change. Whereas the weights will change based on the gravity. Next is about volume and density. So volume is the amount of space occupied by a substance, and the unit of volume is length cube. The unit of length is meter. So the unit of volume is meter cube or centimeter cube or decimeter cube. So we can say that the volume is a derived unit. It's derived from a basic unit called length. Okay. Next is about density. Density of a substance is its amount of mass per unit volume. Amount of mass per unit volume. Density is equal to mass per volume or mass by volume. So this is again a derived unit, and the SI unit of density can be obtained as follows. That is, SI unit of density is equal to SI unit of mass per SI unit of volume. So SI unit of mass is kilogram, and of volume we just derived it is meter cube. So kilogram per meter cube or kilogram meter cube inverse. As volume and density are two derived units. And next is about temperature. There are three common scales to measure temperature: degree Celsius, Fahrenheit, and Kelvin. We used to measure body temperature in degree Celsius, room temperature either in Fahrenheit or in degree Celsius. There are places where they measure in Fahrenheit, and some places used to measure room temperature in degree Celsius. Whereas Kelvin, or K, the symbol K, is the SI unit of temperature. Now the temperature on two scales are related to each other. We can convert the temperature from Fahrenheit to degree Celsius or Kelvin to degree Celsius. But the relationship between the Fahrenheit and the degree Celsius is, if you want to convert into Fahrenheit, as 9/5 of the temperature in degree Celsius plus 32. If you do this calculation, you can convert the temperature into Fahrenheit. And to convert into Kelvin, if we know that degree Celsius temperature in degree Celsius, we have to add 273.15. So what is the temperature of boiling water, or the boiling point of water in Kelvin scale? We know 100 is the boiling point of water, right? So 100 degrees Celsius. So 100 plus 273.15, if you do that, you get 373.15. That is the boiling point of water in Kelvin scale. And for the freezing point of ice, we know the freezing point of water of ice is 0 degrees Celsius, right? So 0 degrees Celsius plus 273.15, that is 273.15 in Kelvin is the freezing point of ice. Okay, so we have discussed about the SI units and some derived units. Hope this video was useful to you. See you in next class. Take care.